Hello and welcome to another video on basic fiber optics. So on the screen right now we see the emission spectrum of an EDFA as we discussed in the previous video, and it's actually located right here. Now an interesting device we also want to think about in fiber optics is a filter. So that's the one we have right over here. So a filter is just any device that takes in a range of different wavelengths and then only allows through either a single wavelength or a certain range of wavelengths. Let's see how that looks in action. So we're going to take the output of this EDFA here. Let me turn it on first, or rather turn it off. Then I'm going to plug that into the input of the filter up here. So I'm going to unplug this one and clean it, like so. Oh, actually, let me maybe undo that real quickly, because I think we want to take a look at the spectrum here and actually fix that in place so we have it for later. Let me go back to here, press sweep, just do single like so. Oh, forgot the camera. So anyway, sorry about the little interruption there. All I did was just take a single spectrum here, and then go to trace, fix it, and then we want to go to B, display it, write it, sweep it, and then repeat it. That's better, okay. This is really nice because now we can actually measure the power before and after the filter. So in any case, we want to turn this off, and then hook up the output of this EDFA to the input of the filter. So I'm gonna clean this one here again, just in case. And hook it up. Like this. And then we're gonna take the output of the filter coming out of this port here. Oh, see it's taped in place. Tape, and then take this output here now and hook it up to the input of the OSA. So I need a connector, which I have of course not been smart enough to bring in advance. Yeah, this will be fine. So take the cap off here and clean it. So far these tutorials have been mostly just videos of me cleaning and connecting fiber, so I'm guessing you're going to be really good at that once you finish watching all of them. So that's the connector taken care of. Now we of course cleaned the fiber for the input to the OSA as well, and hook it up to the output of the filter. And then let's see what we get. If we enable this now, take a look at the screen. Oh, there we go. So, as you can see, we actually get a little bit of power leaking through right now. Maybe I'll change the span slightly to, let's do like 10 nanometers, I think should be good. There we go. I might even zoom in a bit more. Let's do maybe 3 nanometers. So, yes, there we go. Okay, so what's really nice about this particular filter is that it has 2 knobs for tuning. We can use this one up here to change this into wavelengths. Let me do that. So you can see I can shift the center of the filter around a little bit, so I can actually select out certain wavelengths I want. But this one's even nicer because it also has a bandwidth tuning. Now, not all filters do this, but this one actually does. I think it's actually based on a grading, similar to what we saw for the operational principle of the OSA. So if I tune this, you can see that I can actually filter out a wider range of wavelengths as well, and of course I can still tune it right to left like so. Alright, so maybe I'll try and plug in the handheld laser we've been working with before in order to see this one actually extracting a particular wavelength. So stay tuned. Okay, now I've hooked up the handheld laser source to the input of the filter right here. Then the output of the filter goes into the OSA right here. So let's see what happens when I tune this wavelength here a little bit. We should be able to filter out a particular... Oh, there we go, see? So now we're actually filtering out just a single one of these constituent wavelengths of the filter, of the laser rather. So you'll remember from previous videos that this handheld laser actually has a whole sort of comb with multiple frequencies coming out. But now using this cool device here, I can actually just pick out a single one of them like so, which really shows the utility of having filters. So we've gone from a whole range of wavelengths coming out of the laser to just a single one using this device here. What happens if I tune the bandwidth of it? I can actually capture maybe 2 of them at the same time. So I'm increasing the tuning this knob up here. See if we can capture 2 of the different wavelengths. Not entirely sure if that's possible. Maybe it's a bit too narrow. Oh well. So anyway, I hope this shows why filters are so cool and useful.